Now let's solve this question. In this question, they are saying G1n in this and G2n is this, and they are comparing between G1 and G2, right? So, like in these kind of questions, you might get confused that what to do. Like this n is less than or equal to that, and n is greater than that, and like that, right? So just these are just something just to confuse you. I mean, there is no point in having a function behavior for smaller values. So smaller smaller and bigger values are not defined by some number. It is basically, it could be any constant. Like based on some constant, you can say okay, these are the small values. See, after a certain point, function is just n square. So you can say that for the asymptotic analysis, you can say that g1 n is just n square. Just forget about whatever is happening after like before a certain point, right? So which is n naught. So n naught is basically 10,000, right? So before 10,000, whatever is happening, let's just not worry about it. It is just to confuse you. What about this g2n? G2n is n cube after a certain point, right? G2n is also n cube, and let's fix one point only after which we will be comparing. So after this 100 only, this is n cube, but after this 10,000 also it is n cube, right? So g1n and g2n are actually n square and n cube. So you can say, let's suppose this is the plot. So before that, whatever is happening, let's not worry about it. Like maybe something is happening, and but after a certain point, it is like one function is n cube and one function is n square. So after a certain point, which is actually n not equal to 10,000, right? So you will say that, let's suppose this is n cube, this is n square, which is g1n, and this is g2n, right? So you will say that yes, g1n is actually greater than equal to g2n, right? Why? Because after a certain point, the things only matter. Okay, sorry, it is n square and it is n cube, so it is g2 and this is g1. This is g2, this is g1, right? I hope you got it. So this is g2, this is g1. So you will say g2 is greater than equal to g1n. So you will say g2 is greater than equal to, means g2 should be in the big O, right? So yes, A is true. A is true, right? Very easy question. This is just a piecewise function to confuse you. Now, can you say that that maybe before 100 only, maybe can you say that if n is less than or equal to 100, right? So g1n is n cube. Actually, g1n is n cube. This is g1, okay, g1n, and g2n is n, right? So it is just n. This is g2. So can you say that for less than or equal to 100, can you say that g1 or g2n is equal to order of g1n? Can you say something like this for less than or equal to 100 if n is less than or equal to 100? No, like this is completely I mean nonsense. Like you should be, if you are saying something like this, then actually this means that g2n is equal to c into g1n, right? And here n is greater than or equal to some n naught, right? You cannot bound a function on some limit that okay, for n less than or equal to 100 only this is true or something like that. This asymptotic notations are after a certain point, not before certain point. So this is completely nonsense. I mean, this is okay that g1n is n cube and g2n is something. This is okay. This is perfectly fine. But you cannot compare asymptotically just for the smaller values. Okay. For to compare the asymptotically, you have to have after a certain point, you have like you have to have some bound, like you have to have some turning point, right? So if you are saying that n less than or equal to 100 only, then this does not make any sense. So actually, A is the correct answer. So in this question, they are saying which of the following is false, right? They're asking about the false option. See, this is just a constant, so I think you can ignore it. It is n log n. And this is 100, which is just a constant function multiplied or divided by some constant. So you can also ignore it. So this is as good as saying n log n is equal to order of n log n. So I think that is exactly fine because it is in fact theta, right? If it is theta, then big O and big omega both are possible. So A is actually true. What about B? B is saying log n. So see, both are using log n. So let me just put log n is equal to k, right? So it will be root k and equal to order of log k. Is it true? This is k power 1 by 2. Okay, this is order of log k. Is this true? Just recall yourself that n power epsilon is in fact greater than equal to, in fact strictly greater than log of n, right? Or power anything, maybe power anything. So that's why this B is false, right? B is false. I mean, B is the correct answer because they are asking for the false. What about the C? Yes, C is true. Why? because if you are increasing the power, let's suppose if you are comparing n square and n cube, then obviously n cube is greater. If you are increasing the power, then in fact it is small o, okay, it is small o, like it is a big O, that is okay, but you can also put the small o. And they are saying 2 power n is not less than equal to nk. Yes, this is true. 2 power n is not less than equal to nk. Yes, this is true, right? Because 2 power n is actually strictly greater than nk. So this is also true, this is also true, this is also true. B is only false, that is why B is the correct answer. Let's see this. Consider the following function. Which of the following is true? These are the three functions that are given to us, and they are asking which of the following is true. They're asking us to compare. Let's just compare this fn and maybe hn first. Okay. Let's just compare. See, this 2 and 3 are just constants. Okay, this 2 is not constant. This 3 is constant. So let's just ignore it. Okay. So this is fn, which is n power root n, and let's just compare between hn and this. I think we have done this question, but anyway, it is easy question. Just take log. It will be square root of n, log n, and it is n log n, right? After log, you will say that yes, this is greater. So before log also, this has to be greater, which means hn is actually greater, strictly greater than fn, right? Fn. So that is fine, which means that that hn, like you can say fn is equal to order of hn. So let me do one thing. Let me arrange all the functions in the increasing order or decreasing order, and then we will just see the options. Okay. So this is the case. And what about this gn? Let me just compare gn with any of the function. Maybe let me compare with the fn only. So this is n power root n. Okay, this is n power root n, and this is fn, and this is 2 power root n log 2n. So I think you can take this root n out to the power of n, then it will be 2 power log 2 n power root n. So in fact this is just n root n, right? N power root n. So I think this gn is as good as saying this is n power root n, right? N power root n only. Gn and fn are actually same. So this is same as this, fn is same as gn, which means you can say hn is greatest one. So hn should be in the order. Which of the following is true? So hn should be, so if both are equal, actually if both are equal, then you can say that yes, fn and gn both are equal, so you can say big O, right? Yeah, you can say big O. What about hn? Hn should be inside this big O, so that is why neither this is true, this is true. So D is the correct answer. Let's solve this. N square log n and n log n power 10. So you can easily solve it, I think. So n square log n and n log n power 10. So let's just cancel out the common term. So here this is the common term. Here it is 9. Here it will get cancelled. So n you want to compare between n and log n power 9. So I think you can easily say that n is greater, because you know that n power epsilon in fact is greater than log n power any constant, right? So you can say that n is greater, which means this fn should be within the order. If you want to write, then you can say fn should be within the order. So which means yes, B seems to true, and you cannot interchange it because it is strictly greater. See, it is strictly greater. If both are true, then it will be theta, right? So yes, B is true, right? So you cannot interchange it because it is strictly greater. That is why, right? I hope you got it. Let's see this. N plus k power m is actually same as n power m. Isn't it true? I think this is true. Why? Because the most significant term or the largest term in this polynomial, this is the polynomial of n power m. So largest term will be n power m only. Okay, n power m into k, like whatever, like you can expand this series. It does not matter. Like if you want, you can expand. Otherwise, you do not need to actually expand. So the largest term here will be n power m only, right? So the dominating term here is n power m, and similarly the dominating term here is n power m. So both are actually equal. So yes, this is right. What about this? Can you ignore this constant? Let me just see if you can ignore. So basically it is 2 power n plus 1, and which is as good as saying 2 into 2 power n. So you can write this 2 outside, so that's why you can ignore this. That's why both are actually theta, right? So theta is possible, then big O is possible. So that is why this is also true, right? What about this? So it is 2 power 2n plus 1. So similarly you can write it like, you can actually ignore this 1. Why? Because you can write it like this, 2 power 2n, and then this 2 is EG, so you can ignore this. So now it is 2 power 2n and another term is 2 power n. Which one is greater? You can divide by 2 power n both sides, then this will be 2 power n, this will be just 1. So this is strictly greater. See, this is strictly greater, that is why you cannot write big O here. You can write big O like this. You can say 2 power n is equal to big O of 2 power n plus 1, 2 power 2n plus 1 or whatever, right? You can say like this, but this is wrong. So that is why this is wrong. So 1 and 2 are true. So A is the correct answer. Actually, gate questions related to asymptotic notations are very easy. Okay, you can solve these questions very easily. Now let's solve this question. Fn, Gn, and Hn with the functions, and they are saying the positive integers defined, function defined for the positive integers such that Fn, they are saying that Fn is actually, Fn is lesser than equal to Gn, and Gn is not lesser than equal to Fn. Then what does this mean? If Gn is not lesser than equal to, it means it has to be greater than equal to greater than Fn. So here the first condition is saying less than equal to, which means Gn is greater than equal to. Okay, first thing is saying that Gn is greater than equal to Fn. Second is saying that Gn is actually strictly greater. So second is actually more precise. So using these two conditions, using these two things, you can say that Gn is actually strictly greater, right? What about this? Gn is lesser than equal to. So this is saying Gn is lesser than equal to Hn, and this is saying Hn is lesser than equal to Gn. So which means both are actually equal, right? So both are actually equal. So Gn and Hn both are equal. So you can say that this is equal to Hn. So which means, let me just erase this, which means that Gn, if you compare between all of this, Gn, Hn and Fn, so you will say that Fn is least, and then you will say Gn and Hn both are same. Now let's just see which option is true. Now they are saying Fn plus Gn. See, if we are adding n square plus n cube, then it just means n cube, right? So basically this term, which is Gn, Gn is dominating because Gn is greater. So this is like as good as saying Gn, right? So you can actually ignore this Fn. Now they are saying Gn is equal to order of Hn plus Hn, 2 times adding 2 into something is just Hn. So this is actually Hn. So Gn is equal to Hn, right? Order of Hn. If they are equal, you can put O, you can put theta, you can put big omega also, right? So that is why this is true. So A is true. What about B? B option is saying Fn is lesser than equal to Hn. So Fn is lesser than equal to Hn. Yes, this is also true. What about this? They are saying Hn is not lesser than equal to Fn, which means Hn is greater than Fn. Hn is greater than Fn. Yes, this is also true. What about this? They are saying Fn into Hn, right? Fn into Hn is greater than, not lesser than equal to, means greater than Gn into Hn. So Hn will get cancelled out. Fn is greater than Gn, which is false, right? So that's why D is the correct answer, because D is false. Now I think we have solved this question before, but for the sake of completion, let me do it. This is 2 power n. I think 2 power n, n factorial, we know which one is greater. Like Gn is actually strictly greater than Fn. And what about this n power log n? So let me just compare this n power log n to one of the term. Maybe I can compare with the 2 power n. So n power log n and 2 power n, which one is greater? So let's just see by taking log. So if you take the log, it will be log n into log n, which means log n square, it will be just n. So obviously this is strictly greater. So 2 power n is strictly greater, which means Fn is strictly greater than Hn, right? So this is the order. So based on that, you can find out which one is true, right? They are saying Fn is less than equal to Gn. Yes, true. And Gn is less than equal to Hn. So Fn is less than equal to yes, but Gn is not lesser, right? Gn is the greatest one. So Gn, like you can say that Gn is lesser. See, they are saying Gn is lesser than equal to Hn. So this is false, right? So that is why this is not true. What about this? They are saying Fn. They are saying Fn is greater than equal to Gn. So Fn is greater than equal to Gn. This is false, right? This is false. So this is also false. What about this? Gn is lesser than equal to Fn. Gn is lesser than equal to Fn. This is also false, because Gn is actually greater. What about this? Hn is lesser than equal to Fn. Yes, that is okay. And Gn is greater than equal to Fn. Yes, that is also okay. So D is fine, right? Because Hn is lesser than equal to Fn and Gn is greater than equal to Fn. So that's why that is fine. Okay. Arrange the following functions in the increasing asymptotic order. So let's just arrange these functions. This is n power 1 by 3. This is n power 7 by 4. So you can just compare the powers. So 1 by 3 is greater or 7 by 4 is greater. Let me just take, let me just multiply by 12. I think maybe it is, if you multiply by 12 both sides, then it is actually 4 and it is 7 into 3, right? So you will say that this is greater. So 7 by 4 is greater. So obviously this is greater. And e power n is exponential, right? So you can compare between B and E just by comparing this E and 1.0001. So since E is greater, so that's why you can say B is actually greater than E, right? B is greater than E because this E is 2.7 or something, and then it is just 1.00. So B is greater than E, and I think B is the greatest one. And these are the exponential things. So this is the exponential family, and this is polynomial or log polynomial. So let me just compare between this D and C. Okay. So you know between C and A, right? C is greater than A. Let me compare between D and C. So you can say that it is D is n into log 9n. So log 9n is as good as saying log n power 9. Okay. So it means n into log n power 9. And the second thing is n power 7 by 4. N power 7 by 4. Okay. This is not n power. I mean, this is just log n power. So it is n power 7 by 4. Now you can just cancel out n first, right? If you just cancel out this, so 7 by 4 minus 1, it will be 7 minus 4, which is 3 by 4. So it is log n power n, and this is just 3 by 4, n power 3 by 4. So n power anything is actually greater. Okay, log n power 9. This is not log n power n. Yeah, n power anything is greater. So you can say that this thing, which is C, is greater than D, right? C is also greater than D. Then let me just compare between A and D. So A and D. So it is n power 1 by 3. It is n into log n power 9. So obviously this term is greater because it is just n power some small thing. This n itself is greater than n power 1 by 3. Then obviously this will be greater. So D, between D and A, D is greater, right? So you will say D is greater. So you will say C, D, A. This is the order. And here B is greater than E. Then you will say B, C, D, A is the order, right? In increasing function. So A, D, C, A, D, C, E, B. So A is the correct answer, right? I hope you got it. Now, if there is any confusion that why this B and E are greater or lesser, see, whenever you have some term, let's suppose n power x, n power y, then you can just compare between x and y, whichever is greater. If x is greater than y, then you can say n power x is greater than n power y. Okay. And what about if the base are different and power is same, which means power is, let's suppose, n and base are different. Let's suppose it is x power n and it is y power n. Then if power are same and base are different, then also it is applicable. You can say if x is greater than y, then x power n is also greater than y power n. Okay. So here you can say that if e is greater than this, then e power n is also greater than this. Okay. See, these are basically greater than one values, right? So it will also increase. Like these are the increasing functions. So for the increasing functions, you can apply these things. Now let's solve this question. In this question, they are saying which of the given option provides the increasing order of asymptotic complexity. So they're asking you to arrange these functions. So I hope you can solve this question, but let me quickly solve also. So see here, this is 2 power n, this is exponential, then obviously this has to be greater than this term. What about this term? This is a bit tricky, like you can't directly say that this is greater than this because it is n power some function, not just constant. It is not a polynomial. So you can say that yes, f1 is not lesser than f2 and f3, but let me just compare f1, which is 2 power n, and n power log n, right? Let me compare these two terms. Maybe let me take the log. It is log n and log 2. Sorry, this is n log 2, right? This is n log 2. So you can say it is n and it is log n into log n. So log n square. So obviously this is greater. So you can say f1 is the greatest one. So either this and this, and then you can say between this, like you need to compare between this f4 and f3 and these things. So maybe like I think you can easily compare. So let me just do between f3 and f4. So f3 is n power log n, and sorry, f4 is n power log n, and f3 is n log n. This is f3, right? So let's just compare these two. So it will be like you can cancel out the common terms if you want. So it is n power log n minus 1, and this is log n, right? So what do you think? Like this is just log n, and this is n power some function. Even n power some constant is greater. So n power some function is obviously, which is an increasing function, right? So this is obviously greater. So f4 is greater than f3, right? So you can say f1 is greatest, and f4 is greater than f3. So yeah, and between f2 and f3 also I think we need to see between these two. So let's just compare between n power 3 by 2 and n log n. So You can easily compare. If you cancel out the common term, it will be 3 by 2 minus 1, which is n power 0.5, right? It is 1.5 minus 1, so it is n power 0.5. So obviously n power 0.5 is greater. So you can say f2 is greater than f3, right? So f2 is greater than f3. So I think A is the correct answer. Okay. Let's see this. So they are incomparable, right? As we know, 1 plus sin and n are incomparable. So they are saying which of the following statement is correct. So none of them is correct. D is the correct answer, right? Because they are not comparable. I think this is very easy question. You can do it. Okay. This is GATE 2017 question. Very easy question. You can do it easily. You can just ignore these constants maybe. Okay, there is no constant. Yeah, this 100 you can ignore. So which means you need to actually compare between root n and log n and 1 by n, right? So 1 by n is decreasing function actually. So since it is decreasing function, by after some point it will eventually be 0 actually, right? So it is even worse than 1, right? I mean some constant which is 1, 2, 3 like that. It is very lesser number. So 1 by n or 100 by n or these things are like very small. So you can put this. Okay, there is 10 also. This is constant, so it is actually lesser than the constant also. So this is the worst, which means 100 by n is worst, and then this constant. Then you need to compare between these three functions. Then I think then log n will come, then root n will come, then n will come. Log n, root n, n. So B is the correct answer, right? Okay.